Hey, welcome back, calculus students. Today we're looking at 3.3 part 2. We're looking at product and quotient rules, so these are super important. Going forward, there's something that you need to remember and be able to apply. So the product rule it applies to for finding the derivative with respect to x of two things that are multiplied together. So what it's going to look like is we're going to have the u times the derivative of the v plus v times the derivative of the u dv plus v du. Pretty straightforward, and you're going to see how it works out in a second when we do the examples. The quotient rule is very similar, so if we have the derivative with respect to x of u divided by v this time, what we have is the v times the derivative of u minus the u times the derivative of v divided by v squared. I know I left all this space in here, but there wasn't enough room for the next stuff, so let's go ahead and check it out. It says find f prime of x, which is the derivative, if f of x equals x squared plus 1 times x cubed plus 3. So notice that we have this thing times this thing. This would be our u, this would be our v. So let's go ahead and apply our product rule here. So we do have a product because we're multiplying the u and the v. So we're going to write it derivative with respect to x of u times v is going to be equal to u dv plus v du. So it's kind of helpful sometimes to just write it out. So let's say we have u x squared plus 1. V is x cubed plus 3. The derivative of u would be, well, we're going to apply the power rule, right? So we drop down the 2, subtract 1 from the exponent, so we'd have x to the first. We don't need to put the first power there. And then we said that any constant that we have derives out, so that's 0. So du is 2x. Let's do the derivative of our v now. So we drop down our 3, x, and then we subtract 1 from the exponent, so that would be squared. And then the 3 is a constant that derives out as well. All right, so let's put this all together. So we have u, which is x squared plus 1 times dv. So dv is 3x squared plus v x cubed plus 3 times du, which is 2x. I suppose we can multiply this out, so let's go ahead and distribute these and then simplify as much as we can, and we should be done. So we get 3x squared times x squared is 3x to the 4th plus 3x squared, and then we have 2x times x cubed is 2x to the 4th plus 2x times 3 is 6x. We can combine our like terms. So then we have 3x fourth plus 2x to the 4th is 5x to the 4th plus 3x squared plus 6x. So this would be the derivative of the whole thing. Now keep in mind, there could be other ways to do it that might be longer. Like for example, if we had multiplied this out in the beginning, we'd distributed our stuff out here, we'd end up with, what's that? X to the 5th. X squared times 3 is 3x squared plus x cubed plus 3. Right, we could do the derivative of this at this point, right? Because we just have a polynomial. We'd have 5x to the 4th. Let's do this x cubed next, so it'd be 3x squared. And then the derivative of this would be 6x. The constant becomes 0, so notice that both ways we get the same answer. It's just that we might not always be able to multiply stuff out and get a polynomial out that we can that we can derive easily. So yeah, there's not always one way to get the answer. There's multiple ways many times, but some ways are easier than others. So just keep that in mind as we move forward. Okay, next one. Find f prime if f of x equals x squared plus 1 over x squared minus 1, over x squared plus 1. So this one is going to be, notice that we have this top here, this bottom here, we're dividing. So this is going to be a quotient rule. The u would be the top, the v would be the bottom. So we're going to say, okay, quotient rule, derivative with respect to x of u divided by v is going to be v du minus u dv over v squared. Okay, so let's kind of list this down. So we know that u is already x squared minus 1. V is going to be x squared plus 1. The derivative of u is going to be, well, power rule says we drop down the 2, and we have x to the first. The minus 1 is a constant, so it derives out. Okay, now derivative of v, same idea. Drop down the 2, x to the first, the 1 derives out. So let's construct this whole thing. So we got v du. So v du minus u dv all over v squared. So x squared plus 1 squared. Okay, one huge hint, or one huge tip. This is a minus sign. It applies to everything on the right-hand side. So be very aware of that, because it's easy to forget and misplace signs and end up with the wrong answer. Let's go ahead and distribute this. And distribute this just so we can simplify a little bit. So 2x times x squared is 3x cubed. 2x times 1 is 2x. Minus, and I'm going to put parentheses here, right? Because we said the minus applies to the whole right side. So we're going to do 2x times x squared is 3x cubed again, minus 2x. Okay, now we can subtract. So 3x cubed minus 3x cubed, that's 0. 2x minus negative 2x, be careful there, that's going to be 4x. Okay, and then the bottom stays the same, and we're done. All right, the next one's really weird looking, and they're giving us a ton of information, but once you understand what it's asking us to do and how to apply it, it's not that bad. So it's saying, let y equals u times v. So it's some function here times another function there. They're not even saying what those look like. All right, so they're asking us to find the y prime of 2 if, and they're giving us all this information. U of 2 is 3, u prime of 2 is negative 4, v of 2 is 1, and v prime of 2 is 2. So the important thing here is that they're giving us these things at the point we're looking for, right? So these are all at 2. If they don't match up, then we really can't do anything at this point, but we can because they're all at 2. So remember, this is just a product of two things. So we know we're looking at a product rule, which is u dv plus v du. And again, we're doing product rule because we're multiplying u and v, right? Even though we don't know what they look like, we have two things multiplied, we can product rule. So all we have to do is fill in our values here. So the u is 3. dv, the derivative of v is 2. And then v is 1. And du is negative 4. So what we have to do is multiply and simplify. So 3 times 2 is 6, plus 1 times -4 is -4. So this whole thing, y prime at 2, is going to be 2. And we can do that even though we don't know what the functions look like, because we know what the values are at 2. Okay, so pretty simple. It can be totally confusing and weird if you're looking at it for the first time and you don't understand what it's asking you. But yeah, it's just saying, here's the information. This is a product. So it's asking you to, 1, recognize it's a product and we should use product rule. And then 2, realize that we can just plug in the values for each of these, for the u's and v's, and the du and dv. Okay, so the next one says find y prime if y equals x squared plus 3 over 2x. Now, yes, you can quotient rule this, and it'll come out fine every time. But also remember we said that there's other ways to do it. So if you do recognize this as a situation where we can apply algebra to split this into 2 fractions, then it might be easier, right? So if we look at this and say, all right, well, this, because we have this single term in the bottom, I can just write it as 2 fractions and say we have x squared over 2x plus 3 over 2x. And then we simplify a little bit. So we say y equals, and then we can cancel the x in the bottom with 1 in the top. So we have x over 2. And the second part, because we know that we're going to apply our power rule, we're going to rewrite this as x to the -1, right? So we do that because it's in the denominator. If we want it to be switched places, if we want the x to reciprocate, we make it a -1. And that's going to allow us to apply power rule easier. So when we do our derivative, the x, we're going to drop down the 1, and it's going to be x to the 0 power. So this whole thing is going to be 1/2, this first part, when we apply power rule to it. The second part is going to do, well, we're going to drop down the 1, so it's going to be negative x to the -2, because we subtract 1 from the power. So that's one way to do it. Keep in mind you could also do quotient rule and you should come out with the same answer. But just showing you that there's multiple ways to do the different things. And as long as you don't break any algebraic rules, and as long as you follow along with the derivative rules, then you should be fine. It might take longer, it might take shorter, but as long as you don't break any of those rules, then you'll come out with the correct answer in the end. All right, last one, and it's just asking us to find first 4 derivatives, and this is kind of leading on to the next stuff in the unit, but just know that we can take different derivatives, different layers of derivatives, you might say. So the first derivative of this, we're just going to do it by parts, right? So we're going to drop down the 3, subtract 1 from the exponent. So the first part is 3x squared. The next part, we're going to drop down the 2. So we have 2 times 5 is 10. And when we subtract 1 from the exponent, we just have 1. So we'll leave it as that. And then the constant derives out. The second derivative is denoted with the 2 ticks. So we're just going to take the derivative of the derivative. So if we're looking here again, drop down the 2. It's going to be 2 times 3 is 6x minus 10. Three tick marks, that's the third derivative. 6x derives out to be 6. The 10 is constant, so that's gone. And then y to the fourth, or the fourth derivative, would be 0. Right, because the derivative of a constant is 0. So there's your first 4. And it's important, and we'll kind of talk about it, because when we're talking about the physics aspect of calculus, what we can do is, if we have a function denoting our position given a time, then the derivative of that function would be the velocity given a time, and then the derivative of that would be the acceleration given a time. And you don't really look any further than that too often, but if you went to the fourth derivative, that would be the jerk. So like the amount of force placed, well, how much jerk you feel from the acceleration at that time. All right, that's it today. Hopefully it wasn't too much. Hopefully these ideas sunk in a little bit. But yes, very important to remember product rule and quotient rule, and know that they're always out there. They're always active. So if you come to some problem where you might not know how to solve it using the rules that we've done, well, the basic rules, power rule and stuff like that, try to see if the product and quotient rule apply. And we'll kind of talk about it as we learn more techniques to do our derivatives, the hierarchy or what we should be looking for as we derive problems that are unfamiliar to us. All right, good job.